You can pour all the fertilizer you want onto a field, but if the chemical state of the earth is off, it won't matter. Plants physically lose the ability to absorb nutrients in poor soil, leaving crops stunted right next to thriving ones. This pH scale measures soil hydrogen ion activity, running 0 to 14. Exactly 7 is the neutral baseline. Values below 7 are acidic, matching lemon juice. Values above 7 are alkaline, similar to seawater. For most crops, the safe zone sits between 6.5 and 8.0. To test this in the field without a laboratory, we use the NICE Soil Testing Kit. The essential chemical components for this test are the pH reagent 1, pH reagent 2, and a decolorizer powder. Diagnosing this invisible metric directly in the dirt is a necessary step. You cannot accurately apply a single soil treatment until you know exactly where your field sits on this scale. You start by walking your field and taking 10 to 20 subsamples. At each spot, dig a V-shaped cut 2 to 6 inches deep. Combine all these small collections together and let them air dry to create a single composite sample that accurately represents the whole area. From that dried composite pile, measure out exactly 10 cubic centimeters of dirt and pour it into your mixing tube. Now we start to chemical extraction. You add exactly 25 milliliters of pH reagent 1 directly into the soil tube. Then you must cap the tube and shake it vigorously for a full 5 minutes. This specific time frame is required so the reagent makes contact with every single soil particle, effectively pulling the hydrogen ions out of the dirt and into the surrounding liquid. At this point, the liquid inside the tube is extremely muddy. Because the final result relies on reading a delicate chemical color shift, this dark, murky water is useless. To strip the cloudiness, we add a pinch of the decolorizer powder, marked as D1. Once it's in, you agitate the tube again to mix it thoroughly. With the decolorizer mixed in, pour the entire muddy solution through a piece of filter paper resting inside a glass funnel. Let gravity do the work, and watch the liquid drip into the flask below. You must verify that the resulting solution is completely clear before moving forward. Now we trigger the final indicator. Add exactly 4 to 5 drops of pH reagent 2 to your cleared liquid, and give it a gentle swirl. Set the flask down and wait 2 to 3 minutes. The reaction takes time to fully manifest. That colored, crystal-clear solution sitting on the table now securely holds the precise pH signature for your entire field. Hold your colored liquid against the official pH color chart in natural daylight. Yellow blocks at the top mean intensely acidic soil. A green middle band indicates neutral territory. Purple or deep blue means you are dealing with high alkalinity. Now prescribe the exact fix. For highly acidic soil below 5.0, apply half to 1 ton of lime per acre. Is above 8.0, the soil is alkaline. Apply half to 1 ton of gypsum per acre to pull it toward neutral. The entire diagnostic process relies on an unbroken chain of actions. Take the soil, extract with reagent 1, clear with decolorizer, filter the liquid, trigger with reagent 2, and match the chart. By mastering this chemical sequence, you've pinpointed one of the most significant hurdles to plant nutrition. Identifying a pH failure is a definitive first step towards restoring a field's ability to sustain life.